Hello, Transitional Algebra 2 students. This is Mr. Pashar here. I'm hoping everybody is doing healthy, well, and is safe during this pandemic. I do miss you guys, but I'm happy to be able to teach you from home today your next topic, which is function composition. I understand, trying to navigate the algebra waters is a little bit tough at home just by reading a textbook, but I appreciate your efforts. Everybody I know is giving the best effort based on what conditions we have. And I just ask for you to keep working your best. That's all I ask. But today I'm going to talk about this new topic, function composition. So you will get lecture notes emailed to you at the next assignment. And the next assignment is lesson 8.1 from your textbook. So watch out in the email for your new assignment. What we're going to talk about today is this function composition. Now, if you have me in Algebra 2, you know a little bit about this. If you haven't had Algebra 2, you may not know anything about this, and that's okay. I'm not expecting you to do. But what is function composition? Well, here's two examples of notations that you may see when you're reading your textbook. So the one we'll look at the bottom first is one your book definitely does have. This G with this open circle, an F, and an X. And that's equivalent to writing this. This is the easy way of saying it. What this is G of f of x. G of f of x. So it's like a function being plugged into a function. And we have f of g of x, f of g of x. So this time the g function is being put into the f function. Now, I always like to give the analysis of the Coke machine, right? So you remember how this worked. We had 50 cents goes in to the black box and you get out Coke. That's how a function works. Well, composition works the same way, except we're going to have two black boxes. So we start out with plugging in x, right? So think of it this way. Your x goes in to your black box, and this first black box is f of x. So you put x into your function f of x, and that gives you out f of x, or as we also write, y. X goes in, y comes out, right? You know that. But if we want function composition, primarily this one right here, we're going to now take this y and we're going to put it through a function machine again. So this is the g function. And after y goes through the g function, what you're left with now is g of y. And what is g of y equal? That is g of f of x. So that's how function composition works. X goes into the f black box, spits out y, but we're not done. We're going to pass it on to the next black box, which is the g function. That does its magic, and that gives us g of y. Just like this would be y equals f of x. This is g of y, and what does y stand for? Well, y always stands for f of x. So g of f of x. That's schematically how function composition works. The good news is, to do the actual algebra is not really all that difficult. And if you pay attention to the lecture notes that I sent you, I think you'll be able to go through it. So what I'm going to do here is just go over a couple of the examples from the lecture notes. And I'm going to give you a couple additional examples that aren't in your lecture notes that you can practice with. And I think that'll help you with the homework. So let's get rid of this and look at some examples. Functions are predominantly in every branch of mathematics. You can't escape working with functions. And just like we could add, subtract, multiply, and divide numbers, we could add, subtract, multiply, and divide functions, and perform what we call composition. So let's look at an example that you had in your notes. This was example 1. F of x is the function 2x, and g of x is the function x squared plus 2x plus 1. Okay? And I'll get a different piece of chalk here. Okay. So what we want to do is figure out what is g of f of x. So here's this weird type of notation. This isn't an O. It looks like it says goff, right? But it's not goff. It's g of f of x. So right away when you see this, your first step before doing any computation is to rewrite it as g of f of x. That's your very first step before you do anything else. Just rewrite it. See, this looks a lot better than all this crap here, doesn't it? Now, what does this mean? Well, you go from the inside out. Your inner function is an f, you see? So what this means is everywhere you see an f of x, you're going to plug in the 2x. So our next step is to say g of 2x, because 2x stands for f of x. You see? Now you've seen this before. G of 2x, what does that mean? That means we go to the g function, which is x squared plus 2x plus 1, and everywhere you see an x in that g function, you're going to go ahead and plug in 2x, okay? So here we go. So this is going to be 2x squared plus 2 times 2x plus 1. And just like that, the hardest part of the problem is done, because the hardest part of the problem really always is the setup, just plugging in the information. So let's recap again. We have g of f of x. You start with the most inner function, which is f. Our f function is 2x. So that's going to be g of 2x. So here's your g function over here. Everywhere you see an x in the g function, you're going to go ahead and plug in 2x. So we got 2x squared plus 2 times 2x plus 1. Now at this point, you just go ahead and do the stuff that you know how to do. 2x squared, that means it's 2x times 2x. So that's 4x squared plus 2 times 2x, that's just 4x plus 1. So this is your final answer. 4x squared plus 4x plus 1. So when we combine these two functions together through composition, we get this brand new function. Kind of neat. A linear function, a quadratic function, gives us back some quadratic function. What you should do is pause this video at this point to go back, see if you can do this problem. So I'll give you a moment to do that, and I'll show you something else then. Now, this isn't in example 1, but let's just add it to it. What if this time we want f of g of x? So that came from, well, what I should do is probably write it with the ugly notation so you can see first. But we just want to change this slightly. And we want to do this. We want to do the composition of, it looks like it says fog. We say this as f of g of x. So our first step, just like in the last problem, we want to go ahead and rewrite it. So we write that as f of g of x. The second letter is the one that's in the inside. So again, we work from the inside out. Your inner function is g of x. So that means we have f of this function. X squared plus 2x plus 1. So now we want to evaluate f of x squared plus 2x plus 1. So that means everywhere you see an x in the f function, you're going to plug in this trinomial. So we're going to have 2 times x squared plus 2x plus 1. You see, all we did is we took this and we plugged it in right here because we want f of that stuff. And then this is very simple. You're just going to go ahead and multiply. So that's 2x squared plus 4x plus 2. So notice that we do not get the same answer as in the last problem because we reversed the composition. Now, you'll learn this someday, but if you reverse the composition and you get the same thing, that tells us something special about the two functions. It tells us that they are inverses, but that's a different topic that'll come a little bit later. So once again, I encourage you to pause the video, take a look here, see if you can redo this problem. And we'll check back with you guys in a moment. Okay. So one more type of example I'm going to show you is what happens if we want to evaluate the function at a specific numerical value, not just some generic x. And that would pop up in example number 3 for your lecture notes. In that example, f of x stands for x cubed plus 1, and g of x stands for x squared minus 1. And we want to find this. What is g of f of 2? G of f of 2. Well, the process is still the same. It's a composition, and we want to do what's on the inside first. But what's different this time is we're looking for a specific x value to start out with. We want f of not x, but f of 2. So what we want to do is kind of go off to the side and figure out what f of 2 is going to be. So that means we're going to plug a 2 in for the f function wherever there's an x. So that's going to be 2 cubed plus 1. That's 8 plus 1, which is 9. So f of 2 is 9, and that's going to get substituted right in here. So g of f of 2 is going to be g of 9. So this actually is a little bit easier when I ask you for a specific x value like this number 2. So g of f of 2 we found to be 9. G of 9, what is that? Well, we just go into the g function and figure that out. That's 9 squared minus 1. 9 squared is 81. Take away 1 is 80. So the answer here is 80. Pretty nifty, huh? It's not too difficult to do. It actually makes our work a little bit easier when this is a nice concrete x value instead of just the generic abstract x. So once again, I'd encourage you to pause the video, see if you could go back and figure it out. And what I'm going to do in the next example is just go ahead and switch the order. Okay, so how about we look at a question like this one. What is f of g of 2? So what is f of g of 2? So now we reverse the composition, right? So we want to start out by asking what is g of 2? So let's go off to the side and think about that. What is g of 2? Well, that's that g function over here. So that's 2 squared minus 1. And that's going to give us, on a normal day, 3. So g of 2 is 3. So that means that's going to go right up here. So f of g of 2, that's going to be f of 3. Right, so we found it to be 3, so we go to the f function and plug in 3. So we've got 3 cubed plus 1. 3 cubed is 27, and add 1 more gives you 28. And that's how this composition works. Again, it's kind of cool because we're given a specific x value, so it makes the work a little bit easier to do. So that would be 28. I'm hoping that you're able to follow this. I don't think it's too bad. So again, leave it up to you to pause for a moment, and I'll show you one more example. I'll make up an example as the last one that's not in your lecture notes, and that'll be it for the video. So let's see if I can cook up an example that's a little more challenging maybe. Let's say we have f of x is x plus 1 over x minus 1. And how about g of x is, let's say, how about x squared? Let's find f of g of x. So g of x stands for x squared. So we have f of x squared. That's not so bad, right? So f of g of x, first step, g of x replaced with the x squared because that's what the g function is, given by x squared. Now, this is f of x squared. So this is your f function, this quotient, right? So everywhere you see an x in this quotient, you're going to slap in an x squared. So it's going to be x squared plus 1 over x squared minus 1. There's really nothing you can do. You cannot, and believe me, I know there's some of you guys that would be illegal chopping the heck out of this thing, but you can't. There's nothing we can illegally chop, so don't you dare come and say that this is going to be negative 1. That's bad. You've been doing better than that at this point in April. All we could do is keep it like this. If you wanted to be a hero, you could write the bottom as x times 1, x minus 1 times x plus 1, but it's not required. Either of these answers is fine. In fact, I would probably just leave that one there. Now the question is, what happens when we go and compose this baby the other way? I think it might be just a little more slightly challenging. So let's see. So let's do g of f of x. So that's going to be g of x plus 1 over x minus 1. Yeah, that's kind of nasty, doesn't it? Look that way. So g of x plus 1 over x minus 1. But don't let it get, don't be discouraged. Follow your rules. So g, so everywhere you see an x, you're going to plug in this ugly quotient. So it's going to be x plus 1 over x minus 1 quantity squared. You can either leave it like that or write it as x plus 1 times x plus 1 over x minus 1 times x minus 1. Either one would be fine. And there's really nothing else we could do with this function. So I hope these examples helped you. Please read over the lecture notes. They'll be emailed to you. And if you have any questions, remember, please call or email between 11 and 1 during the regular office hours during the week. So until next time, stay safe, stay healthy, and I'll see you when I see you.